Hello friends, welcome. ನಿಮಗೆಲ್ಲ ಟೆಕ್ ಟಾಕ್ ಟುಡೇ elective technique ಅಂದಾಗ ಸ್ವಾಗತ. Let us discuss few more solutions as a part of preparation for KEA exam of KPTCL 2022. So this question is again from the subject control systems. Okay, let us look into the question first. There is a characteristic equation given that it is s to the power 4 plus 4 plus 3 plus 24s square plus 32s plus k is equal to 0. And we have to calculate what is the value of k. Okay. For what positive value of k does the polynomial is given over here have roots with 0 real parts. Okay. There is 10, 20, 40 or 80. Now, basic simple rule is, as we have already solved a similar example in our previous part of video, that is write down S4, S to the power 2, S to the power 3, 2, 1 and 0. So now we have to write down the coefficients for S4 and S4, there is even terms, which is 1, 24 and next is k. Similarly for odd numbers, which is 8 and 32 and 0. Okay, we have to write down these coefficients. Now if you can solve for this, then the complete solution is made available in this slide. So if you can go through the complete solution, right. So we'll get the complete solution as 32 minus 2k divided by 5. Right. So we should get the solution as you can see here, it is 32 minus 2k divided by 5 is equal to 0. Now simply we have to solve for this. So if you can solve for this, then we'll get the answer for k as 80. Right, so we should get the answer for k as 80. This is the required solution, and you can mark this as option B. So this question is again from the control systems subject. So it says that the position and acceleration error coefficient for the open loop transfer function given over here, you can see that g of s is equal to k divided by s squared into s plus 10 into s plus 100. So whether the position and acceleration coefficient, whether that is 0 and infinity, whether there is infinity and 0, or whether that does have any other value, that we have to determine. So in order to determine this, okay, so first we have to solve for this g of s with limit s tends to 0. Okay, with limit s tends to 0. So if we can solve for this with limit s tends to 0, then we should get the solution as infinity. Similarly, that is called as the position error coefficient. Okay, this position error coefficient is the value of kt, which is determined by letting the s limit to 0. Similarly, for acceleration error, which is ka, for acceleration error, which is ka, we have to solve for this for limit s tends to 0 for the transfer function s square g of s. Okay, so we have to multiply s square to the transfer function given over here, which is g of s. Okay, if we can solve for this by again getting s limit to 0, if we can solve for this, then we should get the solution as 0.001k. Okay, so 0.001k, if we can solve for this, this is nothing but k divided by 1000. Okay, so from the available options, we can see that the value of kp and ka are infinity and k over 100. So option B is the answer for this question. Next is this question is from the subject logic design. It is given that a full adder can be implemented with half adders and OR gates. So if we have to make 4-bit parallel full adder without any initial carriage, then how many adders are required? Okay, for this we actually require 7 half adders and 3 OR gates. So we require 7 half adders and 3 OR gates. So this is again maximum efficiency of a amplifier. So this is from the subject analog electronics. Okay, so the maximum efficiency we have to determine. Now by just looking into the values given over here, and initially it has been proved that the maximum efficiency we shall get is 50%. And you can also guess that it cannot be 500%, it cannot be even 5%, or it is also practically 0.5 also, ultimately not at all possible, right? So option B, which is 50%, is the answer for this question. Now this is again from the analog electronics subject. This says that the slew rate in an instrumentation amplifier will be, so generally it will be as high as possible. Slew rate must be as high as possible. Now let us look into the technical aspects of this. The slew rate of the instrumentation amplifier must be as high as possible. It is mainly to provide maximum undistorted output. Okay. Output voltage of a given amplifier must be undistorted. So that is the reason that the slew rate must be as high as possible. Now next question is again from the same subject, analog electronics subject. Okay, now what does we have to calculate here? We have to calculate the input resistance required. Okay, the input resistance required we have to calculate. Now what will be the input resistance of a voltage series feedback amplifier having a gain of 300, Ri of 1.5 kilo ohms and RO of 50 kilo ohms and beta of 1/15. Now to calculate the required value of resistance, the formula is Ri R equal to Ri into 1 plus beta into Kb. Right now if you can solve for this, we know that Ri is 1.5k, 1 plus beta is 1/15 into Av is 300. Now if we can solve for this, then we shall get the solution for this as 1.5 into 1 plus, so 20 into 1 will be 20, 20 plus 1, 21. Okay, so 21 into 1.5 if you can multiply, then we will get the solution for this as 31.5 kilo ohms, right? So for this question, the answer is D. Next, this is a very simple question from electrical machines. So most of the questions, at least 30% of the questions which are asked generally for AE exams are from only 2 subjects. One is electrical machines, another one is from electrical power systems. Okay, so these 2 subjects can fetch more marks. Now it says that the current in armature conductor in a DC machine. So as we know that since the armature is rotating and since the current, whatever we are speaking is about the armature conductor, and that since it is always rotating, it is always AC. Current in the armature is always AC. The conversion takes place at the later stage of the DC machine with brush assembly and commutator, but with the current whatever is asked in the question is in the armature conductor. So in the armature conductor it is always AC. So DC shunt motors are used. So as we know that DC shunt motors are generally used wherever constant speed is required and static conditions are not severe. Not severe means the load demand or the torque demand is not high. In such cases we have to use DC motors. So it is practically constant speed motors. Efficient motors are known as practically constant speed motors. So next is again from the machines, the primary and secondary of a transformer are coupled. They are actually coupled electromagnetically. They are not coupled only electrically, they are not coupled only magnetically, whereas they are coupled electromagnetically. Next is the transformer does not possess changing property of power. Okay, so power changing will be not associated with the transformer. Next is the torque characteristics of three-phase induction motor. So the torque characteristics of three-phase induction motor is similar, very similar as that of DC shunt motor. Next is this is about the percentage slip calculation. Okay, so it says that a 4-pole, so number of poles is 4, frequency is 50 Hertz. It operates at slip of 5%. 5%, nothing but what is 0.05. The frequency of induced EMF we have to calculate. So the frequency of induced EMF is called as F bar is equal to S. Yeah, that's it. Let's see 0.05 into 50, which will be 2.5 Hertz. Okay, 2.5 Hertz is the answer for this question. Next is turbo alternator uses. Okay, turbo alternator is nothing but we are actually speaking about synchronous generators here. Okay, synchronous generators are also called as alternators, right? So these alternators are used where the alternator construction, mainly the rotor part. Okay, we know that there are two types. One is salient and the other is non-salient. Okay, what has been asked is turbo alternator uses which kind of rotor construction. So please try to understand that whenever we say that the word turbo, meaning for this is high speed. The meaning for this is high speed. Now there is a comparison given over here. You can see that salient pole rotor, okay, and cylindrical. Okay, cylindrical is also called as non-salient. Okay, so salient pole have larger diameter and shorter axial length, and they are generally used for low speed. But cylindrical, since they have smaller diameter and longer axial length, they are used for high speed turbo alternators. Okay, they are used for high speed alternators, turbo alternators. And remaining comparison you can see with respect to the projecting poles, salient, no projecting poles, non-salient, and so on. And salient poles require damper winding, and the other one does not require any kind of damper winding, and so on. But with respect to the question which has been asked here, high speed turbo alternator means non-salient or cylindrical rotor. That is, non-salient pole beam structure is used for turbo alternator. Now, what is the role of damper winding in the synchronous motor? Yes, that has been asked here. So synchronous motors are generally not self-starting. The synchronous motors are generally not self-starting. And main role of damper winding in a given synchronous motor is to make them self-starting. That is, the machines are made self-starting by providing a special winding in the rotor poles, which are also known as damper winding. Okay, so in that context, option B, which is that the damper winding serves to start the motor, is the option to be considered. Next is the cheapest plant in operation and maintenance, which of course we know that is hydroelectric plant. Next question is about the demand factor. Okay, the demand factor is generally it will have a value less than 1. As you can see here, right, it is given by maximum demand divided by. As we know that always the numerator function, whatever we have the maximum demand, will be always having maximum value, and in the denominator whatever we consider it will be lesser than that. Let us say that it is 1 in the load whatever is that 0.9 so we can consider this always maximum into 1 will be less than 1. So self GMD concept, okay, it is geometrical mean distance. Is actually geometrical mean distance. Okay, the concept of GMD is used to calculate inductance. Remember that it is only applicable for the calculation of inductance. Next is the consideration for higher and higher operating voltage of transmission line. Okay. So this is we know that electrical power is transmitted at high voltage always. What is the reason? Main reason is that it will increase the efficiency of the transmission line. It will also reduce the power loss. So thus admittance matrix of the power system is not. Okay, so you can ask that why does possesses certain characteristics. So it is actually symmetric nature, square matrix, full matrix. Right. So generally having diagonal elements. So among this you have to check out the option which is not relevant, which is not a characteristic of a, which is not a characteristic of a white. What is it? Okay, it is actually symmetric matrix, square matrix, and generally having dominant diagonal elements. But it is not a full matrix. It is not a full matrix. Okay, that is the option of select option C. So reactance relay is a concept which uses directional restraint over current relay. Okay, it is a directional restraint over current relay. That is option number 2. Select. Okay, friends, we shall stop our discussion for this part of video here, and we shall continue our discussion in the next video.